very much. Thanks for organization committee for the opportunity to present this work. So I'm going ahead. We focus on practical matters, practical experience of using special approaches and special methods to optimize working with big data storages. As we with my co-researcher work in a field of big corporate storages, big data, and very performant processing systems. So we examine and demonstrate how can we optimize and boost the performance of such massive data processing systems. So our main idea is integer surrogate case for date and time labels. This transformation, the transformation using integer surrogate case instead of traditional native data formats, this transformation allows to optimize the performance of these databases. It provides practical approaches, absolutely practical approaches to boost the performance of the system with very simple and very robust algorithms. So we replace standard date and date timestamps with 32 or 64-bit integer formats. And this reduces storage automatically. This reduces storage for time series, for logs, for transactional data by 30 to 60%, and this can have a very big meaning for practical applications for corporate systems with terabytes of data, terabytes of such data. And also, this approach, together with reducing the storage, this approach allows us to speed up query execution by notable tens of percent, 25, 40% faster. We get the result, we get the report, we get the analysis, we make our risk management or fraud prevention system working. And this is drastic change. This is really practical effect. So what exactly do we do? Let me go further. The core issue is that native date and date time and timestamp types take a lot of space to store. So they are inefficient when we are talking about high-load systems, when we are talking about systems with mass data processing. And currently, such systems are all around us. So these are telecommunication systems, financial systems, Internet of Things generate a lot of data, a lot of time series, a lot of logs, a lot of data to analyze and somehow store, somehow report, etc. So by 2028, we expect almost like 400 zettabyte of data, and 1/3 of them, nearly 30% of them, will be time series, will be data of logs, will be transactional data, and somehow telemetry. So standard time formats require 30 to 50% more storage than optimized solutions. You see values. That we treat 30% of 400 zettabyte. It is like 120 zettabyte of data. And we may we may reduce this amount of data, this volume, by 30 to 50%. It is a drastical change. It is a drastical change in the world scale. And this is something that has to be done. Also, using native data types, using native timestamps causes additional special limitations. So we have high storage overhead. We have limited precision. Our date time formats have a limited precision that is critical for example, cryptocurrency applications, where we care about every nanosecond, and every nanosecond matters. So traditional time formats, traditional data formats are not precise enough to give all necessary tools for us to work. In the world scale, for world scale applications, for worldwide applications, we face a problem of time zones and daylight saving time, and daylight saving time changes, and so on and so forth. And when you architect, when you create such a world scale system, you must deal with these changes, these time zones consistently, and consistently on every node of your system. That is very, very hard, following the practical experience of doing that. And when you do filtering, when you do aggregations, when you build reports, etc., in most cases, when you deal with time series data, one of your filtering parameters is date time range. So you need to filter by date, you need to filter by time, you need to search by time and date, and native formats that are being treated in systems like strings obviously give a low efficiency of filtering, of aggregation, of reporting. So almost 50 or, I don't know, 70% of built-in reports is waiting for filtering by date range. And this is critical. This is absolutely critical. And if we reduce these expenses, this time expense, this time cost of doing filtering and aggregation, we boost 3 times, 5 times, we boost the reporting systems very much. And so our proposed solution is following. We just replace native date or timestamp formats with compact integer representation that is integer surrogate case in terms of this work. So key benefits. Key benefits of such changes are following what I have said before. So we have faster queries. We have faster inserts due to specific internal implementations of database engines, of storage systems. Our inserts work much faster. And if we talk about logs, if we talk about transactional data, that is thousands of inserts every second, it is critical, and it gives more efficiency to do something else, something specific. Then we reduce storage. We reduce storages, we reduce storage requirements, and we optimize cost of operations of our system. Storage and storage space is one of top items in our budgets, in our expenses. So this is a big part of total cost of ownership, And if we reduce storage, we get immediate and obvious financial effect, financial return on these investments. Then precision. As I said, now we have cryptocurrency, we have financial operations, we have very fast Internet of Things applications. So we care about every nanosecond. Every nanosecond matters. And that's why increasing the granularity, increasing the precision of our data storage boosts us a lot. Then we simplify. Then we simplify architecture of our system. We simplify algorithm. We simplify processing of time series, time data by elimination of time zones, daylight saving time, and so other anomalies in time zones schedule. And these formats are that is simple. So format 1 is 32-bit integer. That stands for date. And this is just date-specific data. When you care about only a day, you use this format, and this is much smaller. This is much more efficient than storing this date in standard native datetime format. Why? Just because of size. 32-bit integer, 32-bit integer is just 4 bytes. Native date stores in 4 bytes record, so it's 16 bytes, 4 times more. And when we just replace all dates in some example financial application database, that almost everything is date. Date of transaction, date of report, date of storing data, date of registration, etc., etc. We may reduce the storage completely by 40 or 30 or even 60%. And that's why this is a simple change. Just go and do. Just take and replace this type, having such a big benefit. When we care about nanoseconds, we can use format 2, that is 64-bit integer. It stands for year, month, day, hour, minute, second, and microseconds precision. So it works for very, very fast applications like high-frequency trading, like cryptocurrency processing, like arbitrage on financial markets, like monitoring of frauds or threats, etc., etc. You must react to threats very, very fast. To react to threat, you have to detect threat, obviously. And your fraud detection system must be absolutely fast, maximally fast to detect these frauds in real time. And that's why if you use such a format, you are in a game. You are working quite fast to detect fast threats of modern world. What do you do with these formats? How does it work? First, indexing and range search. When you work with date, you understand that native datetime format works like strings. So this is very, very slow and very complicated searching and indexing. And what do? You just create an index not on date time, but on integer presentation of date time. And creating index on integers is something that databases are created around. So everything optimized to work with integers. So you are using the most optimized mechanism of database engines. And you just do a simple change. You add time to int call into your code, and you drastically improve the performance of your indexing. 25 to 40% in real-world applications. Definitely, we can invent, I don't know, 100%, 200% applications, artificial applications that show 100 or 200% performance increase. And this would be illustrative. However, for real world, it stands for tens of percent. Then time series and date ranges is something to filter by and to search by in modern applications. That's why you hit the most optimized mechanism of databases, searching by integers, ranging by integers, filtered by integers, and you get up to 3 times performance improvement with such change. You just replace a format and you get a drastical improvement. These are simple implementations. What to go then? Aggregation. You may aggregate by integer bins. You start with a bin, you get 10 to 20% performance increase using bins based on integers. And batching with grouping operations and group processing of operations, if you use integer presentation and if you group your operations quite intellectually, you get the optimized batching with integer presentation. Let's go further. Even more complicated thing. We can use data encoding and bit packing, something like similar to SIMD BP128 algorithm. You store the first timestamp fully, and then if we have a quite stable, quite rich time series, we may store only the difference between following timestamp, following records. And this would allow us to compress the complete system, the complete time series very, very efficiently. And if we have a real high frequency time series, like regular logs, like transactions in a high loaded system, we may compress data size very notably. Next practical applications. If we use international atomic time for internal storage, we completely abandon any inconvenience and any problem caused by delay saving times and time zones. So we use internal atomic time for calculations and integrity. We store it in integer view, and we just convert this time, this internal atomic time, to some user presentation just on user interface only. And we do it knowing where the user and what is the time zone, what is the settings of his or her system, and it works very well. Specific implementation details. To automatically maintain integer timestamps, you just create a table specifically. It is how it is generated, and you get integer replacement, you get integer surrogate case for every record that comes into your base. It's simple. You see, the syntax is quite obvious for anyone who even did not work with the database. In ClickHouse, we have a very powerful mechanism. So ClickHouse guys were thinking of that method. They were thinking of optimization of their engine, and they embedded this mechanism into native implementation of ClickHouse. So in ClickHouse, you just call the integer timestamp and use it, and you get it. Well, it sounds like advertisement of ClickHouse, but this is just an experience. What we get in some practical case, just to understand, just to measure what we do. These were a set of financial applications and telecom applications, because I was working a lot in telecommunications and finance, so my professional specialty is finance and telecom and fintech. So we get a database, we try to do some things in original presentation and in improved presentation. Building reports, inserting logs, working with anti-fraud systems, calculating some aggregate values. So in general, we have 35% faster insert. We have almost 40% faster range queries. Like, show me my operations between this date and that date. We have 39, like 40% faster aggregation day by day. So we get daily report. We close the day 40% faster. And when we batch operations, when we process operations massively, we noticed up to 8 times faster increase in records per second processing by batches. So results are notable. Let's summarize how to apply. First, finance, high-frequency trading, and telecom. Finance, nanosecond precision and microsecond latency. It is achieved by using by storing data in 32-bit format of integer, and we get efficient partitioning. So we process every day very efficiently. When we process call detail records in telecom, we have to aggregate billions of call records every day. So we store call date as int, and we aggregate these records by int aggregation parameter. And this gives us faster group by operation, and terabytes of storage are saved by that. When we care about industrial Internet of Things, like freight transport security system that I was implementing all around the Europe. We handle massive data streams with thousands of sensors. We have to store information. We have to store logs and data coming from these sensors. So we split timestamp to 2 integer fields, date and time. So date we use, as above mentioned, we use date for aggregation and storage and filtering, and we use time to process, sort, and somehow treat specific events. It's easier to generate integer packets on simple devices with limited calculation abilities, calculation performance. It is much more simple for them to generate two integer numbers instead of string representation of native data form. Future scope. This approach comes to industrial leads and big guys adopt the approach for them to get benefit. So Meta uses that in their Scuba. High-frequency trading operators use this approach to optimize their operation, their performance, and get benefit. ClickHouse, as I said, implements it natively on the level of platform. So we see the following steps in standardization of integer time format usage. Hardware acceleration. We connect. Think of it. Imagine that we connect database engine with graphic processors for performance purposes. So this will boost databases by graphical card and will boost NVIDIA. I would say 3 or 5 times more, and we may generate, standardize, and provide better compression algorithms for query optimizations. To conclude, I said integer-based timestamp storage is a highly efficient method for time series systems, for modern systems that are working in real time. We get performance gains, we get resource saving, and we get enhanced accuracy when we need that. So we use it in high performance, high frequency trading, high performance systems of Internet of Things, etc. We use them when storage matters, when volume of storage, when amount of data matters. And we use it when nanosecond precision is required. Nanosecond or even more. I work in femtosecond range and now in my, let's say, scientific investigations. However, I have to mention that there are some applications where to avoid the proposed method. We avoid them when we have small projects, when we have simple projects where it's simpler to work with date like as date. Just startup, I don't know, educational applications, etc. When we have systems that have complex date arithmetic out of the box. So you process data, you do some data calculations, and you use a platform, your platform to provide abilities, to provide functions to calculate dates out of box. And when we build a microservice or something like that, the system with ORM, object relation model, heavy project. So we use interfaces. We talk to some lines, some components from the others that we do not manage. So as we do not manage them, they understand what they understand. So if they understand date, we have to send date, not our integers. And that's it. Thank you very much. I'm open for your questions.